But how are a million or so ones and zeros wirelessly transmitted every single second between your smartphone and your wireless earbuds? In order to answer this question, we're going to explore the engineering behind Bluetooth and the principles of wireless communication. Before we get into the details and specifics of Bluetooth, let's start with an analogy. When you see a traffic light change color, you recognize what that color change means. The traffic light uses a section of the electromagnetic spectrum, or light, to convey information. The green light has a wavelength of around 540 nanometers, yellow around 570 nanometers, and red around 700 nanometers. Your eyes can easily distinguish between these different wavelengths of light, and your brain interprets these different wavelengths and the information they convey. Your smartphone and wireless earbuds communicate using electromagnetic waves in a rather similar fashion, but utilizing a different section of the spectrum. Specifically, Bluetooth uses waves that are around 123 millimeters in wavelength. They are invisible to the human eye and can generally pass through obstructions like walls, rather like visible light passing through glass. When your smartphone sends a long string of binary ones and zeros to your earbuds, it communicates these ones and zeros by designating a wavelength of 121 millimeters as a 1 and a wavelength of 124 millimeters as a 0, similar to the 540 nanometer green and the 700 nanometer red colors of the traffic light. Your smartphone's antenna generates these two wavelengths and switches back and forth between them at an incredible rate of about 1,000,000 times a second. With this process of switching between the two wavelengths, kind of like switching between the red and green traffic lights, your smartphone can communicate around 1,000,000 ones and zeros every single second to your earbuds.